We continue our lecture with a new chapter here, which is chapter 7. And this chapter 7 is a continuation of previous chapter, which is chapter 6. So that means we are still talking about the supply side of the equilibrium, but previous chapter it was about labor demand and labor supply and labor market. But now we want to talk about outputs and also price level on the supply side of the economy. Before I go into detail about this, let us do a bit of not that much of revision, but at least you know what we are talking about. I'm talking about here. So when we talk about the supply side, we are basically looking at the aggregate supply. If you can recall back what you did in your first year of your undergraduate study, you did see aggregate supply. You also saw aggregate demand, and then you can have aggregate demand, aggregate supply here, output, price here, and then you can determine the equilibrium. So now we want to focus on aggregate supply here, okay, because we have covered the aggregate demand from chapter 1 until chapter 5. So now we are talking about the supply side of the economy. So basically, when we want to talk about the aggregate supply, what you saw in your first year study is basically the upsloping aggregate supply. And then you didn't know whether you're talking about Keynesian aggregate supply or classical or other things, because it was just a basic introduction. So here, when we talk about aggregate supply, we want to derive aggregate supply. How to derive? We derive it from the production side. That means we have production function. We also have input, and in this case, we talk about labor market. Okay, and then from here, we can determine the number of employment in the market or in the aggregate level. Okay, number of employment and also the output produced. And then what happens to the price level. Okay, but in order to come up with this, we need to have, of course, certain assumptions and also theories. And here, for all of the discussion here, we divide the discussion into two different parts. The first part is using graph. The second part is using mathematical derivation. So we're going to look at the first and the easier one, and then we move to the mathematical derivation. So I hope this is clear. Now, when we talk about aggregate supply here, like I said earlier, it is upsloping, so you draw price here and also output here or income here. When you see P here, price, it's actually actual price, not the expected one. Okay, so what you have seen in your undergraduate level is the actual price. But now, in order for us to start analyzing the aggregate supply, also the supply side of the economy, we relate aggregate supply with the expectation of economic demand in the whole country or in the whole economy itself. So let's look at the expectation, and in this case, we want to look at the relationship between actual price and also expected price. All right, so let's begin. So this is what I'm talking about just now. We look at the relationship between this is actual price and then this is expected price, right? And the relationship is basically expected price depends on actual price, and the value is between, you know, the value of dependency is basically between 0 and 1. That means if you have P prime here, small letter p, it's also equivalent to delta PE over delta P. If there is a change in actual price, let's say increase in actual price by 1 unit, what happens to expected price? Expected price will increase or not, depends on the value here. Okay, so if small letter p prime here refers to, you know, the relationship between how much expected price changes when actual price changes. If the value is 0, what does it mean here? If actual price increases by 1 unit, then expected price, you know, doesn't change, constant. So that means change in expected price by 1 unit, change in change in actual price by 1 unit doesn't change expected price. So the change in expected price is 0. You get what I mean here? But if you look at the second point here, if we have P prime z equivalent to 1, that means change in actual price by 1 unit relates to the change in expected price also by 1 unit. So actually the change here is actually the delta sign, yeah? This T delta. You use triangle here when you study undergraduate level, but because we use mathematical expression all the time, we don't use change here. We use this symbol delta. Okay, you get what I mean? But we move to the third possible value. What if the P prime here, the small letter P prime is more than 0 but less than 1? So that means P prime is between 0 and 1. So what does it mean? If there is a change in actual price by 1 unit, the change in expected price is actually less than 1, but not negative, yeah, because it has to be between 0 and 1. So this is in the form of mathematics. Intuitively, economically speaking, intuitively you're using economic intuition. What does it mean here? It's very simple actually. You look at yourself as human being, economic man, that always involved in many economic activities. It's not only about buying and selling or anything. If the way you expect price, what happens to price, also depends on the way you look at what happens to actual price, isn't it? Let's say we use non-economic example. Let's say you see person A. You know that person A is very hardworking. Okay, hardworking refers to P, actual price. And PE here is the results of exam. So PE, expected price, is the results of exam. What is the relationship between the results of exam and also the hardworking of the person, whether a person is hardworking or not? Okay. So this is the analogy that I can give you. Another thing is that let's go back to economic intuition here. Yeah? Usually, the way human being or people or individual person expect what happened to the price, usually they look at what happens to actual price, existing one. Let's say today, we know that the actual price of nasi lemak, the basic one, yeah, nasi lemak, the basic one is, let's say, 2 ringgit. What do you expect to happen to the price of the same nasi lemak in the future? Let's say within next year. Okay, in the future. Do you think that it's going to be the same as today? Yes, I think so. If you say I think so, that means your expected price, okay, is actually the same as the way you look at the actual price. So if expected price change by, if today's price has increased by, 1, for instance, so you expect in the future, you expect in the future the price of nasi lemak also increase by 1. So you're referring to this, isn't it? But sometimes, maybe you think because economic condition nowadays is not so good, so selling nasi lemak is not that good because of coronavirus and everything. Maybe the price still increase in the future, but only some proportion of, actual price of nasi lemak today. Some proportion only, let's say 0.5, half of it increased by half of today's actual price, for instance. Okay? So if actual price today has increased by, what? So expect the price of nasi lemak in the future only increase by 50 cents, for instance. Because of, let's say, nobody wants to buy nowadays. We only include the increase in the price because of inflation in terms of input production, price of input such as rice, such as chili. You know what I mean here? Because nasi lemak consists of rice and chili. Okay, so perhaps we are talking about number 3 here. But if it is 0, whatever happens to actual price today, change or not, my expectation about future price of nasi lemak won't change. I mean, it would be the same. Okay, the price won't change, price would be the same. I expect that, and so I'm talking about the first possibility here. Now, these three different possibility can be related to economic school of thoughts. Yeah, so we have three economic school of thoughts: extreme Keynesian case, classical case, and imperfect foresight. For imperfect foresight, so what is the opposite of imperfect foresight? Perfect foresight. What does it mean? We'll talk about this later. Alright, so let's look at the extreme Keynesian case. Now, like I said, we have two ways here that we need to look at. First, by looking at the graph. Second, by looking at the mathematical derivation. So, we want to analyze three different cases by using graphs. So, let's look at the first one. Extreme case of Keynesian. So, if you can recall back, in labor market, we have this, okay, number 2. Whenever you see P here, equivalent to capital W, then we're talking about nominal value, yeah? So this is actually what? This is actually nominal labor demand when we use nominal wage. This is actually labor supply. We have seen these two in previous chapter 5. Now let's say we have extreme Keynesian case. It is basically where P prime, small letter p prime, is actually 0. Recall back, expected price is a function of actual price. So when you differentiate it with respect to capital P, which is equivalent to small letter p prime, and is equivalent to 0. What does it mean? The change in actual price is, increased by 1 unit, but the change in expected price is 0. So here 1, here 0. Okay, so it is basically an increase in actual price, which is capital P, does not change expected price, which is PE. So this has something to do with the concept of money illusion. So how can you visualize money illusion in this case? Money illusion is very simple. Okay. You look at yourself when you don't expect the price to change here. That means what? Actual price, we always view income in nominal term, not in real term. Let's say you receive £1,000 this month. So you can buy £1,000 worth of goods and services, isn't it? And let's say next year there's no increment in your income. So you receive £1,000 as well. But next year you don't realize that you can only buy goods and services worth only, let's say, 950. And you thought that by receiving £1,000 next year, you can also purchase the same value of 1,000 worth goods and services, but in fact it is not. So when you feel this way, and you don't realize this bit, then you have what we call money illusion. You don't recognize the increase in price or inflation. You don't take into consideration inflation. Okay, so if this is happening, what happens to labor supply? Remember, labor supply, household, it comes from household. So, and if you supply labor, you receive income. But if the way you look at income is this way, then of course it may affect your decision on supplying your labor hours. For instance, if I offer you, okay, next year still the same salary, so you still want to offer more of your labor supply without understanding the concept of inflation. For instance, perhaps if I don't increase your salary next year, if you understand the concept of inflation and you don't have such kind of things or called money illusion, then you may turn down my offer because it's not ready to work with me. I better get another new job which can offer me more than £1,000 next year. You get what I mean here? So it has some implication on this labor supply. So if we relate this money illusion with the extreme case of Keynesian case, so you can see here, let me erase the mess first. So you can see here, that's why the person with money illusion, they don't change the way they expect the price to happen in the future. So that's why the change in the price, expected price is zero. Even if the actual price increases, you get what I mean here, or changes. Okay, so this case is suitable for a very short run movement in aggregate supply actually, yeah? So not aggregate supply and also aggregate demand, yeah? So because it also can affect aggregate demand later. Get that one later. Okay, so we can try to put this in the form of graph here. So look at this carefully. We use 4 different parts of graph. The first graph here is for labor supply but with nominal wage. So quantity of labor, not labor supply, labor market. So this is labor market. Okay. So now, let's say initially labor demand is this, and then initial labor supply is this. So initial nominal wage is this, capital W naught, and then initial employment in the market is this, N naught. Okay, now we move to the second graph. This is still labor market, but this time we use real wage. So recall back, real wage is equivalent to capital W, which is nominal wage, divided by actual price. Okay, now here, and so we have labor demand using real wage, which is this, and then we have labor supply using real wage, which is this. This is initial expected price, PE naught, divided by initial actual price, P naught, and then we have GN. Alright, so initial real wage is W naught. Initial employment is N naught. Okay, now W naught is actually, let me erase it, this is wrong. Small letter W naught is actually equivalent to W over P naught. Okay, is it clear? With the initial price level. Okay, and we'll show this. Okay, so we don't have to write naught here. All right. Okay. So this one is A. This one is A prime. Let's move to the third graph. The third graph here we have output on the vertical axis and employment on the horizontal axis. Therefore, I can draw total product N and then fixed capital. So it is very sure that it is short run. Yeah? Now, currently N naught is here, Y naught is here, right? So then I have starting point here. We have P, we have Y, real output. Starting point here, P naught, Y naught. This one is A double prime. This one is A triple prime. Okay. So we want to derive aggregate supply curve for extreme Keynesian. Remember, for extreme Keynesian, small letter p prime, which is delta PE over delta P equals to 0. Right? Now, let's say actual price increases from P0 to P1. Okay? P0 to P1. Look at the first graph here, which is labor market using nominal wage. Which curve will be affected? It is very obvious. You can see actual price in labor demand. Can you see P0? Now P0 has increased to P1. What do you expect? Of course, labor demand will shift to the right because of increasing price. You can see here, right? So let me draw it. So it will shift to the right. P1 Fn. Alright. Now, what happens here is that employees or household will see nominal wage increases from W0 to W1. So employment increases. Right? Now what happens to the second graph here in which we have real wage? Now you look here, initial real wage is W0, small letter W0, this one here. It is nominal wage W0 capital letter divided by actual price P0. Now actual price has increased. So you look here, W0 increases P1 and then this one increases. So the whole thing here decreases, isn't it? You get what I mean? That means real wage should decrease. Real wage should decrease from W0 to, let's say, W1. So you look here, from W0 to, let's say, W1. Alright? But how do we explain it in this graph? You look here, it will obviously affect which curve? Let me erase this one. Let me erase this one first. The price can be seen, actual price can be seen in supply curve. For the second graph, can you see this one? So this one will be affected. That means supply curve for real wage will be affected, isn't it? Now you see, PE, P0, this one increases, okay? So what happens? The whole price decreases. That's what they think. But then, I'm sorry, not the whole price decreases. I'm sorry, this is a mistake. Sorry. Actual price increases to P1, okay, such that P1 is more than P0. But because of money illusion, they don't realize that the real wage has reduced. Okay, they don't realize that the real wage has reduced. So here, when the real wage has reduced, what they see is, increase in nominal wage only. So when they see increase in nominal wage, when the real wage is reduced due to price, then they increase the supply. You get what I mean? Because by thinking that increasing real wage could give them more income, so they increase their supply. But they don't realize real wage has decreased. So that is money illusion happening here. That's why they can supply more labor and employment increases. So we have here, B prime. When employment increases, you look at the production curve here, the third one. So employment increases more than N0, output increases. y1 to y1. Okay, and remember price has increased from P0 to P1, and we have more, y1 is more than y0, so we have y1 here, price is here, so this is B double prime, B triple prime. You join the 2 points, you get aggregate supply, which is absolute P for the extreme case of Keynesian. Okay, alright, so that's for Keynesian. So here, what you can see in the first and the second graph, this is the first and the second graph, what Labour sees is increase in nominal wage. Okay, but what they don't see, they don't feel in the short run period is the decrease in real wage. Their purchasing power has decreased. So it's like what I said earlier. In this case, you receive 1,000. Then let's say you receive 2,000 on your pay slip nominal wage, but you don't realize increase in the price. So you think that you can buy goods and services worth 2,000 like before. That's why you want to offer your labor supply more here, because you think you can gain more. So that's what happened. In the second graph here, you can see labor supply shift from PE naught over P naught GN to PE over P1 GN. So you can see employment increases. Employment increases, output produce increases, and then supply movement along the curve from A triple prime to B triple prime. Alright, so that's for extreme Keynesian case. It is obvious that the labor does not adjust to the change in actual price, so that's why there's no change in price expectation. Okay, as a consequence, you can see output still increases because they still supply labor in real term, because they don't realize that their income, although it has increased in nominal term, because they have money illusion, they don't realize that the real term of their income has reduced. Alright, so we move to the second one. We have classical case. Now, let's say we want to talk about the real value of labor demand and supply here in expression 3. So we have equilibrium in labor market in which labor demand equals to labor supply. This is labor demand, this is labor supply. Now, the classical case is where we have perfect foresight in which if there is a change in actual price, let's say increase in actual price, they will lead to the change in expected price by the same amount of the change in actual price. Okay, so that means delta PE over delta P is actually equivalent to 1 perfectly changed. So that means the labor is perfectly adapted to the change in actual price. They realize what happens to the actual price, and then they can predict perfectly what happens to actual price. You get what I mean here? So their expectation is always correct. That's why we call it perfect foresight. Okay, they can always correctly expect what happens. Okay, so we have full adjustment of expectations here, and then here we also want to see the implications of this kind of expectation towards the actual price, the adaptation here, the full perfect adaptation. What's the implication on labor supply? What's the implication in the labor market on employment? What happens to output? And then what happens to aggregate supply of output? So here, the adjustment can be done when people in the long run, because from there they have this history about what happens to the actual price, and they can expect better. So that's why this case is an appropriate case for long run movement, where there is enough time for labor force to process fully new information on price. Previous case, when there is no change in the expected price, that's because the time is still limited. That's why you have money illusion. Okay, so we try to look at it in the form of graph analysis. So again, the same thing, we have 4 different types of graph here. So here we have determination of a supply curve for classical case. Let me push up so that I can get it. We want to see what happens to level supply. We also want to see what happens to output level, employment level, and also aggregate supply. So these are the implications that we want to see. Now, when we talk about perfect foresight, as I said earlier, when there is a change in actual price, the labor will correctly adapt and change their expectation towards price. So that's why the change in actual price is equal to the change in price expectation. Now this can only happen if you have enough information, and enough information can only happen if you have enough time to gather all of these. So this case is an appropriate case for long run movement, okay? Because you have enough time for labor force to fully process new information on the price. Alright, now we want to analyze it in the form of graph. So we have 4 different types of graph here. The first graph is as usual labor market using nominal wage. So here is employment. Let's say we have this demand, okay, and then we have this supply. So initial situation is nominal wage W naught and then N naught. So call this point A, right? And then for real wage, so we have this, N, and then we also have this, Gn PE naught over P1, sorry, P naught, right? So this is W naught small letter, N naught, so this is A prime. And initially for the third graph, this is production function, okay? So Y as a function of labor and also fixed capital. And again, remember, for the long run case here, we only analyze labor, so we have to impose fixed capital, although it is in the long run. Otherwise, it becomes a mix. Okay, so give it that way. So currently, I'm not here. Output level is here. Why not? That is the current initial situation. This is A double prime, and then this is price, and this is output level, initial output Y naught, and then initial prices P naught. This one is A 3 prime. This one. So again, let's say actual price increases from P naught to P1. What curve will be affected first? Obviously, in the first graph, you can see actual price on the demand curve, labor demand curve. So demand curve will increase, isn't it? Or no, demand curve will increase. Okay, so from P naught Fn to P1 Fn. Alright, so the new equilibrium will be at point B, but it won't stop here, so I don't want to draw to label the new nominal wage here, because there will be another adjustment, so I don't want to mess the graph. Alright, after that, you have to remember we have the change in actual price must be equivalent to change in PE. So when price increase, expected price also increase by the same proportion. Okay, by the same proportion. Expected price in the first graph here appears in which graph? Expected price here appears in supply of labor here in the first graph. So supply of labor, because price has increased, yeah, you have to remember initially W naught, the real wage, is W naught over P naught. Okay. Now, when price increases, the P here, the P naught to P1, let's say this one stay constant. Okay. Real wage has reduced. When real wage has reduced, because they have perfect information, okay, because they have perfect information, they know that although nominal wage here can increase up to point B here, which I don't want to label it somewhere here, okay, I don't want to label it because it becomes a mess. Although nominal wage increases, but they realize that a real wage decreases, so the purchasing power decreases. So when price increases, the expectation also increases in terms of price, leads to reduce or reduction in labor supply. So you can see reduction in labor supply here from PE naught to PE1, CN. Okay, so it stopped at point C instead. As you can see, obviously nominal wage increases further. Initially should be, employment increases from N naught to N1, but goes back to N naught. Okay, so because it goes back to N naught, now you look here. Let me use this because I want to show you something. Initially, real wage was this, okay, and then the price increases, okay, and then of course after that the labor adjust their expectation of price, and then because they know that the price is expected to increase, they adjust it exactly the same as what they feel and what actually happened because they have perfect information. So because of that, they demand more nominal wage to compensate the increase in price. So nominal wage increase from W0 to W1 by the same proportion of increase in price level. So it's like offsetting each other. So that's why you can see, okay, because they are offsetting each other, W over P0 is actually W over P1 actually equals to W0. Can you see? So there is no change in real wage, although nominal wage has increased. Because of this perfect combination and perfect adjustment, okay, they adapt perfectly to the increasing price. They demand more of nominal wage so that they know that they don't have to suffer from the increasing price. You get what I mean? What happens in the third graph here? Because there is no change in employment, because employment goes back to N naught, no change in employment at all. No change in employment, no change in output level. No change in output level, but remember, price has increased from P0 to P1, isn't it? Price P1 is here, but output stay the same. Let's call it B total prime. So what happens to aggregate supply? Then you can combine these two points, you get vertical aggregate supply. So vertically shaped aggregate supply. So this is the derivation of aggregate supply curve for classical case when you have perfect information. Now we are done with a classical case. We want to move to another more realistic case. This case is what we call imperfect foresight. So in the imperfect foresight, delta PE over delta P is actually between 0 and 1. So it's actually positive, but it's between 0 and 1. Let's say 0.11. So what does it mean here, class? So if there is a change in price by 1 unit, the price will adjust, the expectation of price will adjust in such a way that increase in expected price is less than by 1 unit, let's say 0.5 only. They don't fully, expect it correctly. That's what it means. So this is for general Keynesian case. Okay, so let's say we have labor market equilibrium for this case in equation 4. This is nominal. Huh? This is labor demand, labor supply. Okay, and because you recall that PE is actually this, so we substitute this by this. Is it clear? In this case, you can see, because if this one is 0.5, this one is 1, therefore you can have change in actual price is more than the change in expected price. They don't perfectly, expect the price to increase, exactly the same as the real one, because they don't have enough information, and that's what we call imperfect foresight. And this is actually happened among us. We don't really can, predict the right, change in anything, isn't it? Okay, so let's try to explain it in the form of graph. How to explain it in the form of graph? Same thing. We have labor market here, nominal. Here also labor market, but for real, small letter w and M here. Here is product market. Here is for the derivation of immediate supply. Okay, now, so let's say initially we have P naught Fn for labor demand, nominal one. We have PE naught Gn, okay, and then we have W naught and naught from this point A. After that, here we have real labor demand, and then we have labor supply, PE naught, P naught, Gn. So initially here, as you can see, okay. So real wage is the small letter W naught, and then employment is here. So let me erase this and let's become a mess here. So here is A prime, and then we have total product, Y, and answer. Also initially we have N naught, Y naught, this is A double prime. Also we have initial situation Y naught, and initial price level P naught, this is A triple prime. Alright, now again the same thing. Let's say price increases from P naught to P1. Obviously, in the first graph, we know that demand curve will be affected, isn't it? Because you can see actual price here. This one here. So, demand curve for labor, aggregate labor demand curve. When I talk about the demand in all of this analysis here, for all of this graph, don't forget to write aggregate labor demand, because we're talking about macro level. So P1 Fn. Right, so call this point P. Right, and then you can see employment increases, and let's say I don't want to mess it up. You know that nominal wage will increase here. But I don't want to mess it up. Let me erase this. But you must understand, nominal wage will increase, because you can see in the table has been achieved. Okay. Alright. So now, when you look here, the labor realize that, okay, over time, price will increase. So when the actual price change, they adjust the expectation and price. They also change the expectation and price. So where the price increase by 1 unit, for instance, because they don't have enough information about how much actual price will increase. So the way they predict is not really perfect. So they may have it between 0 and 1, let's say 0.5. So here it is very obvious, okay, that they have P prime between 0 and This is small letter P, yeah? Okay. So that's the thing. Now because of that, they will also know that although they don't have perfect information, but they know that they have to adjust their expectation of price, because price, they can feel that the price has increased, yeah? Because it's not logic for you to always think that the price decrease in daily life where they don't have any negative thing in economic condition of the country. Okay, so now what happens is that when the price increases, they adjust the expected price here, because they know that their purchasing power will decrease. You get what I mean here? So as a consequence, they are not motivated to supply more labor, because now, unless if you can increase wage rate, that's fine. So they reduce their labor supply. Who reduce labor supply? Labor from PE not GN to PE1 GN. So here you can see there's an increase in price from P0 to P1. At the same time, increase in expected price from PE0 to PE1. But you must remember, the change in actual price is more than the change in expected price, because P prime is between 0 and 1. Okay, is it clear? Alright, so that's how you look at the way I draw it. Because of this, the change in price is not by the same proportion of the change in expected price. So here we have new equilibrium. You can see nominal wage increases from W0 to W1. Okay, so you can see, okay, final position of employment is here, and N2, first N0 to N1, and then from N1 to N2. The net change is increase in employment from N0 to N2. You get what I mean? Why? Because initially, real wage is at W0, which is W0 capital over P0. Now, because nominal wage has increased to W1 and price also has increased to P1, so the real wage has increased to W1. But because they are not increasing by the same proportion, you can see here, they are not increasing by the same proportion. Obviously, it will affect the labor supply also for the labor market in the real wage here. Okay, I'm talking about the second graph. You look here, why? Because initially we have PE0 over P0 GN, isn't it? So now with the new price, okay, PE1, sorry, then we have P1 here, GN. You look at this ratio, it's not going to be the same ratio anymore, because the change has been different. What happens to this ratio? Increase or decrease? Okay, it will decrease. So because it decreases, then it means, okay, what they see here is that, because this one is smaller, this one increase, and this one also increase, but the increase here is more than the increase here. Do you get what I mean here? So the whole thing, increase not as much as, equal to 100%. That's what I mean. Alright, let me explain to you again here, else it becomes confused. Let me use this. Okay, so now initially this one, isn't it? Now it becomes this. Remember, the proportion of change of actual price is bigger than the proportion of change in expected price. So obviously this ratio, okay, will not be equal 1 to 1. You get what I mean here? And because of that, Okay. Because of the expectation is less than what is actually happened, so they think that the real wage won't decrease so much. Okay, so that's why the supply in real term here increases. GN, okay, I mean here. So you can see employment also increases from N0 to N2, similar to this. Okay, I mean here, similar to this. Okay, so N0 to N2 here, output increases to Y. Let's say I don't want to make it a mess. Y2 here, and then Y2 is here, and P1 is here. So we have two critical points. Join the 2 points, we get the aggregate supply. Alright. Now, my question is, let me erase this. We have upsloping aggregate supply for this case. We also have upsloping aggregate supply for the first case here. My question is, which one is steeper? The first case here or the second case here? Can you figure it out? This is your homework, yeah, for your own study. I won't tell you the answer. You must figure it out. I may ask in the quiz, or in assignment, or in project paper and whatnot. Alright, so I have explained to you using graph for all three different cases. Now I need to move to the second method, which is more applicable to the master level in this university. That is mathematical derivation of aggregate supply. Now, mathematical derivation of aggregate supply, you have to look at it carefully. Yeah? Now we know that general rule for equilibrium in the labour market is given by 5 here, in which here we have nominal wage, okay, we have labour demand, we have labour supply here. In real term, okay, we have different. We have in which you have like, real term Fn PE over P times Gn equals to this, isn't it? Equals to W over P. Okay, so this is labour demand, aggregate labour demand, aggregate labour supply, and then real wage. Okay, so I want to show you the derivation of aggregate supply slope. Okay, for all three cases. So look at this carefully, because this is very important. So we know that equilibrium in labour market is given by the following. Okay, I'm rewriting again here. Fn equals to PEG n equals to capital W or nominal wage. All this expression 5 because I'm following the numbering here of equation. What you need to do is that totally differentiate 5. When you totally differentiate 5, let's look at the left hand side here. This is equal sign, left hand side. How do I differentiate it? PFN, so I use product rule. I keep price constant and I differentiate Fn. Delta Fn over delta N times Dn, done. Equal sign. Then I differentiate the right hand side. I haven't finished, sorry. This is product rule. I haven't finished. And then plus. Now, I keep Fn constant. I totally differentiate price. That's the correct way. So Fn constant, totally differentiate price dP. Then you can have equal sign. Now do total differentiation for this bit. First, I keep expected price constant. I differentiate Gn. Delta G over delta N times Dn. Done. Plus, Now I keep, Gn constant. I differentiate PE. Okay, so I write here, yeah, because I don't have enough space. Gn and then times dP. That's it. So I call this expression 7. And then given, okay, PE equals to this, remember, call this 7A. Okay, then totally differentiate 7A gives you this, dPE, isn't it, on the left hand side? Now I differentiate the right hand side, delta P over delta PE over delta P times dP. Okay, I call this 7B. Now, what do we need to do with 7B? Okay, you look at 7B, this one, I use right pen, yeah? Look at this. Okay. This actually can be seen in 7, but I make mistake here, let me show you. This one is supposed to be dPE. Okay, so can you see in 7 dPE? Yes, because I have fixed the mistake here. Here should be also. Alright, so what can we do here? Substitute 7B back into 7. Okay, substitute 7 into 7 here. So substitute 7B into 7. So what do you get here? I rewrite it again. P delta Fn over delta n times dn plus Fn times dP equals PE delta G over delta n times dn plus Gn, and then we put this here. So we have times delta PE over delta P times dP. Okay? So let's call this one 7C. Alright, now we want to simplify expression here. Let's assume expected price equals to actual price equals to 1. That makes our life easier. Then five becomes, you see 5 here that I wrote earlier, this is 5. Okay, this is price 1, this is 1. So what happens? It becomes Fn equals to Gn. Okay, becomes Fn equals to Gn, isn't it? Because price now becomes 1. There's a problem with this computerized pen. Price here becomes 1, expected price also becomes 1. Yeah, so it becomes Fn equals to Gn. Let me write Fn properly. Right. Okay. So next, what we need to do here is that, so let's label this. Let me check here. We have 7C. So this one, let's label this as 7D. Okay. On the other hand, let's use 5 again. 5 at this one, isn't it? So what we want to do with 5, we want to come up with real label markup. Okay, So we have, remember, PFN equals to PEGN equals to nominal, which isn't it? This is 5. What we do with 5, divide both, divide 5 by actual plus P. So what happens? So we can have P over PFN equals to PE over PGN equals to W over P. When W over P, it means real which. Okay, it means real which here. So here, let's call this one, should I put 6 here? I hope so, because I need to check the rest. Oh no, I should put this. Let's say I put 7 for instance. So here, I can simplify it further. I can have Fn equals to PE over PGN equals to real which. Okay, so this is also 7. Okay, so if I simplify further, it becomes 7. Alright, now, what should I do next? We go back to the total differentiation that we have made earlier, which is in 7C. And also 7 here. 7 and also 7C. If you look at 7C here, because this, given that expected cost equals to, sorry, not this one, yeah? Given that we have PE equals to P equals to 1, so what happens to 7C? I use right hand, yeah? What happens to 7C? This one equals to 1, okay? What else? This one equals to 1. Alright, is it here? Okay. So actually, another thing, you look at the, not 5, 7 here. Look at 7 that we have derived. Fn actually equals to real which? Okay, now this equals to 1, this equals to 1, so it becomes 1, isn't it? So therefore, Gn equals to which? If I separate it, Fn equals to which? Real which? Gn equals to real which? Because this one becomes 1, remember? Because of this. Alright, so what can we do now? Actually, if you go back to this total differentiation, can you see Fn here? Can you see Gn here? Okay, so Fn here, I can substitute it with real which. Can you see? Can you see Gn here? Gn here, I can substitute it with real which. Can you see? Alright, so now this one 1, this one leave it just like this one leave it just like this one becomes W, dP, okay, leave it first like this. Okay, this one becomes 1, this one becomes this, and this, and this. Okay, is it here? Right, now. So, let me rewrite this in another better form. Okay, so let me recall back the equation 7C. Right, so using P equals to P equals to 1, okay, also, and this one. use 7D. 7D, we write 5s the following. So how do we write it? 1, okay, delta Fn over delta n times dn equals, sorry, not equals, plus w dp. Okay, I'm sure you know how to get w already. I did mention to you just now, equals to 1 dt dn, sorry, delta g over delta n times dn plus w delta pe over delta p times dp. Okay, so here, that's it. Let's call this one 8. What should you do with 8 here? Okay, what we need to do is that you look at dn. We have dn here. We also have dn here. So bring dn to one hand side here. So we have delta fn delta n dn minus delta g delta n dn equals. Now bring this to the right hand side. The right hand side, it becomes, okay, w dp minus w delta pe, okay, over delta p times dp. Can you follow? Now, on the left hand side, common factor is this. On the right hand side, common factor is this. So we can factorize it. dn with something here equal to whatever times dp. So what I'm trying to say here is that you should factorize based on common factor on the left hand side, which is dn. On the right hand side, common factor is dp. You factorize it until you get something like this. dn over dp, okay, equals to what here? And then that must be equals to this answer. Look at this equation 10 here. Oh no, not equation 10, sorry. Equation 10 this. Okay, dn over dp. This is the correct one. However, we haven't finished. Okay. Why? Because our objective is to find the slope of AS. If we draw AS, let's say this one, you have price here, you have output here. But what you have here is, you have price but you don't have output. So what should we do? We need to do some modification to this equation. Alright, so let's continue. Let's say you already found 10 and I rewrite it here. So we have dn over dp equals to w times 1 minus delta pe over delta p, okay, over delta g over delta n minus delta fn over delta n. Okay, we want to express AS curve slope expressed in the form of y and p. So we call production function is this, isn't it? Okay. Now because capital is constant, therefore we just use n as the factor of output. Now take total derivative of y equals to yn, then you can have something like this. dy on the left hand side, on the right hand side, delta y over delta n times dn. Okay, then you cross multiply this, then you can have dy divided by delta y over delta n equals to dn. Alright, now you see this, substitute this back into this. Okay, so here it becomes dy over delta y over delta n over dp equals, rewrite the whole thing, w. So here in square bracket, 1 minus delta pe over delta p, and then over, okay, delta g over delta n minus delta f over delta n. When I say delta g, it's actually delta gn. It's just the same thing. Okay, so if you rearrange it, you should get something like this. Rearrange them. This is unfinished work. So rearrange it until you get 14. This is simple calculus. I won't tell you how to do it because this is simple maths that you already learn in the high school, how to cross multiply and whatnot. So when you see dy over dp, so we have y here, we have price. Then we can see the relationship between price and output for aggregate supply. So what's the sign here? We want to see the slope, whether it's positive, negative, or what. Then it depends on this. Remember, it depends on this. Whether this one is equal to 0, between 0 and 1, or exactly equals to 1. So let's check one by one. But before we check it, what is 14 actually? 14 is actually the slope of aggregate supply curve. Now the slope of aggregate supply curves depends on this, this, and this, or in other words, it depends on this. Okay, so let's check it one by one. So let's say classical case in which P prime or delta PE over delta P equals to 1. We substitute it here, so that's why you see 1. Then what happens to the numerator value? It becomes 0 divided by delta G over delta N minus delta F over delta N. What happens here? 0. So that means increase in price doesn't change income. So if you put price here, you put output here, income at Y0, price at P0, here, price increase, income still maintained at Y0. So what can you say here? Aggregate supply is a vertical line for classical case. Okay, so now, let's say for extreme Keynesian. So we substitute it by 0 here. What happens here? Then it becomes delta y over delta n times w, isn't it? Over delta g over delta n minus delta f over delta n. So we need to decide whether it's positive or negative. This one is positive. This one is positive, remember? This one is for labor supply. Remember, labor supply slope is positive. This one is for labor demand. Labor demand slope is negative. Negative makes negative becomes positive, positive, positive. So altogether positive. That means If I put it in the form of graph, we have price here, we have output, positive. If price increases, output also increases. So that means it is upsloping slope. Initially, why not? P0. Let's say price increases to P1. Supply of output in aggregate term increases. That's what it means. Okay, so it is upsloping for extreme Keynes case. What about if we have P prime between 0 and 1? Obviously, this becomes, let's say, 0.5. So this becomes positive, isn't it? 1 minus 0.5, because we need to choose value between 0 and 1. So this also becomes positive. This also becomes positive. So it means it is also upsloping, isn't it? This is for imperfect foresight case, yeah? But the question is, if it is upsloping like this, for P prime between 0 and 1, is it steeper than this? Or is it flatter than this? Can you figure it out? So what we have done here, we did study about the slope of AS for 3 different types of theory: extreme Keynesian case, classical case, okay, and also imperfect foresight. Alright, so now we are done with that. The next question is the determinants of aggregate supply curve. When we talk about determinants of aggregate supply curve, that means we're talking about what can shift the aggregate supply curve. Now, if you go back to your principle of macroeconomic study in your undergraduate level, this thing is discussed thoroughly in the textbook economy, or any kind of principle of macro textbooks. Here, we also want to discuss about this, but we want to see not only what happens to aggregate supply, because what we know is that if this is aggregate supply price here, then aggregate supply shift to the right or shift to the left. That's what the determinants of aggregate supply can do to the curve. Okay. Now, usually what we learn, if there is an increase in production function because of technology, when you call back your undergraduate level, increase in technology allow for the same amount of cost, you can produce more. For the same amount of price, you can produce more. So price maintained at P0, initially at Y0, now you produce at Y1. So it must be on the new aggregate supply. So aggregate supply shift to the right from AS to AS prime. That's what we learn. But you didn't learn what happens to labor market and whatnot. So this is the thing that you want to see now. So let's say we have this graph. Initially, we have labor market here for nominal wage, and then we have production function here, and then we have aggregate supply here. So let's say initially P0 Fn, and then we have PE0 Gm. So current nominal wage is W0 and not at point A. So total production is here, Y. Okay. So M0, Y0. So here we have current aggregate supply with current price, P0, Y0. So here A prime, A double prime. Let's say here, other things constant, technology increase. Technology increases. Other thing constant means price constant, okay? And other things other than inside here, nominal wage also constant or whatnot. Okay, now when technology increases, what happens is that how it can affect labor market. it can affect productivity. And productivity will increase for labor, because labor now has more machine to be used in the production process. When labor productivity increases in the first half year, which will be affected? Labor demand. Why? Because productivity is this one, remember? This one is MPN. Go back to your chapter 5. This one is MPN. MPN is productivity of labor. So MPN increases for the same amount of labor. That's why firms are so interested to demand for labor. So demand for labor increases even if price stay the same. Okay? So we have new MPN here. So of course, nominal wage increases, employment increases. Here, isn't it? N1. Okay? But if we maintain the same employment level and N0, then we are here. Okay, let me erase the keyword here. So I don't want to talk about N1, because if I talk about N1, then I have to bring aggregate demand. Here we just want to analyze aggregate supply. So increases here, let's say W2. And in the production function, when technology increases, for the same amount of employment, which is at N0, you can produce more. Let's say Y1. So what happens to production function? Production function shift upward. Okay? Shift upward. Even if employment doesn't change, we don't want to change employment. Other things constant. And remember, price also doesn't change, but output has increased from Y0 to Y1. Y1 is here. Okay, price stay the same at P0. So it's here at B double prime. This one is B prime. This one is B. B double prime is not on the initial aggregate supply. It must be on the new aggregate supply. So you can see, because of technology increase, aggregate supply shift to the right, isn't it? Okay, that's how you analyze it. Is it clear? I don't want to stop here, or I don't want to stop at another equilibrium, because if I stop at equilibrium, then I need to bring aggregate demand here. You get what I mean here? But here, I just want to analyze aggregate supply shift, because we are talking about determinants of aggregate supply. Now let's look at the second one here, changes in labor supply curve. Now, changes in labor supply curve can happen. Let's say you want to talk about increase in labor supply. How it can increase? Let's say women participation increases. That's why labor force increases. So it leads to increase in supply of labor, regardless what happens to the labor market. You get what I mean here? Regardless to, to the price of wage and whatnot. Okay, so what happens here? Let's analyze it. Y here and here. So initial situation is this, being Fn, yeah? Fn, and then labor supply, PE, Gn. Alright. So nominal wage is here, employment is here, production function is here, with N0, output is here. So what about aggregate supply? Aggregate supply, current price, actual price is P0, output Y0. A prime, A double prime. Okay, that's the initial situation. So let's say labor supply increases because of increase in women participation. So of course it affects labor supply here, isn't it? Although expected price doesn't change, but labor supply still increase because of exogenous factor. So PE, G, let's say not here, GN. Let me label it as this. Put it square bracket, prime. So clearly you can see employment increases in labour market from N0 to N1. We move to point B from point A. Nominal wage becomes lower. Also here, employment in the production function, you can see increases from N0 to N1. As a consequence, output increases from Y0 to Y1. But no change in the price. Can you see? No change in the price. So P0 stay the same. Y1 is here. So this is the point. B triple prime. B prime. Obviously, B triple prime is not on the same initial AS. It must be on the new AS curve or aggregate supply curve. AS prime. So increase in women participation has increased the labour supply, shift the labour supply to the right. Alright, now for number 3,